inverse functions of this function, not an invertible function. Well, we can begin by doing the graphical part, and clearly the green thing does not pass the vertical line test. It is not a function. I'm just going to paint one part of that function in a different color. And everything to the right of the vertex, I am going to paint orange. And now I have four functions. Let's talk about this domain restriction. The red function is that quadratic for x less than 2. And the orange function has the same expression, but the domain is different. It's x bigger or equal than 2. But now that I am going to invert algebraically, the next thing that I need to do is to switch this y for an x. This is a y, and this is also a y. And now we are going to use the quadratic formula. We just have to be sure we know what a, b, and c are in the formula. Well, a is 1 because there is nothing multiplying the y squared here. B is this negative 4. And c is 3 minus x. 2 plus or minus the square root of x plus 1. The plus is the blue function, and the minus is the green function. Well, the blue is the inverse of the orange. So that is going to be the G inverse function, which is going to be 2 plus the square root of x plus 1. And then the green function, which is the inverse of the red function, that is going to be the F inverse function, which is 2 minus the square root of x plus 1. And notice how in terms of the domain of these inverse functions, it's all making sense as well, because the domain restriction that we have here is that we can't take the square root of a negative number. So we need to have x plus 1 bigger or equal than 0 for the domain of both of the inverse functions. That means that x is bigger or equal than negative 1, which is exactly what we see in the picture up there. The blue and the green functions only need a domain starting at negative 1 because that is the coordinate of the point. That is the reflection of the vertex of the original parabola.